Okay, we're now live on YouTube for this other webinar for the regional week presented by Veka. So once again, we have Al with us. What is it that you're going to talk to us about in this webinar, Al?
In this session, we're going to look at what's new for Windows in the 2015 National Building Code. And by Windows here, I'm referring to Windows broadly as fenestration, because very often in our everyday conversations, depending on the context, we think of Windows as being anything with glass in it. More precisely, in the code, windows are a type of fenestration product. So I'm using it here broadly. And so we're going to look at what's new for fenestration products in the 2015 National Building Code.
Okay, great. So as always, I want to thank Veka as presenting sponsor and Everlast as gold sponsor. So what we'll do is same thing as usual for those who are used to these calls. We're going to take questions ideally at the end of the presentation. So if there's question at this point, at the end, we'll take all the time we need to answer them. So you can start whenever you want.
Great. Well, thank you everyone for joining us today. This is a new presentation that we've prepared for Fenestration Canada members, but it's also a presentation that we think would be of interest to architects, because sometimes it's hard to keep up with the very many changes that there are in a new code. And sometimes parts of the code that we think are familiar to us and not likely to change dramatically. And there are several dramatic changes of that kind in the 2015 National Building Code. One of them is how we calculate the design pressure of glass, for example. A completely new, well, I would say a new paradigm is introduced in the 2015 code, and that'll be the subject of another talk. But this one has to do with a brand new subsection related to fenestration in the 2015 National Building Code. So what's new? What's new for Windows in National Building Code 2015? A lot has changed. A new subsection 593, other fenestration assemblies, is dedicated to products that are not windows, doors, and skylights. There are new water penetration resistance requirements for other fenestration products, new maximum air leakage requirements for other fenestration products, and there's also new exemptions from air leakage and water penetration resistance for several fenestration products, including commercial entrance doors. All of this is news, news, news if you're in the fenestration industry. So in this presentation, we're going to begin by reviewing the products that are in and outside the scope of the NAFS standard, because there hasn't been enough appreciation that the standard limits itself to a subset of the fenestration products we use in the industry today. Secondly, we're going to look at what the 2010 code had to say about Windows and the problems that created for industry. Then we're going to look at the new subsection dealing with other fenestration assemblies that was introduced in the 2015 National Building Code. And when I get to that point, you'll realize why the fourth topic will be relevant. It'll be tips for using the fenestration performance calculator on the Fenestration Canada website. So, why should we care about the products in the scope of the North American Fenestration Standard? It's actually been surprising to me how few, that there has not been a wide appreciation that the standard known as NAFS, the North American Fenestration Standard, limits itself to a particular set of products. For example, it says this standard specification applies to operating and fixed, new construction and replacement, but here are the products that it applies to: windows, doors, secondary storm products, tubular daylighting devices, roof windows, and unit skylights installed into exterior building envelopes. Okay, what do we mean by these products? Well, we're talking residential windows. We're talking residential sliding doors. We're also talking really big sliding doors that could be residential. They could also be in large buildings. These would be lift and slide doors that are massive. It would include residential entrance doors. It would include unit skylights and roof windows, but small ones that contain one piece of glass.
So Al, I'm sorry to cut you. I just want to make sure, did you want to present a PowerPoint or not? Because right now we don't see your screen.
Are you serious?
Yeah, so I just, yeah,
Oh my goodness. I thought I clicked share screen.
here you go.
Steph, you got to stop me sooner. We got to back up here.
Yeah,
Oh.
it's someone on the line that noticed, actually.
Yes,
I
yes,
didn't
yes,
realize.
yes. Holy smokes. Okay. Let us begin again because, God, we have this fabulous. Okay.
It's okay. It was a trial run.
Yeah. You're right. It's the first time we're presenting this one,
Yeah.
but still, it's kind of annoying. Okay, so we missed the first few slides, but I'm going to start with products in the scope of NAFS. In my presentations, I like to take people into the standard and show them critically important sections, and the same with the code. I think it's really important not just to hear me tell you something is true. I want you to know that there's documentation behind it. I want you to know that if I say something is in the code, I'm going to show you where it's in the code, because it's really important for us to understand that when a message is based exactly on what the code says and not just on an opinion. So this NAFS standard limits itself to these products: windows, doors, secondary storm products, tubular daylighting devices, roof windows, unit skylights installed into exterior building envelopes. So we have residential windows, we have residential sliding doors, but we also, in this standard, address really large lighting stores like the lift and slide doors that we're seeing more and more on large and small buildings. Entrance doors to homes. These did not used to be covered in our older window and door standard, the CSA A440-00. Unit skylights are skylights that just contain one piece of glass, or a roof window would be a operable skylight with one piece of glass, a tubular daylighting device. This standard also covers windows that we might consider high-rise windows or commercial windows, whether they're site glazed or factory glazed. They cover things like architectural terrace doors, which are high-performance balcony doors that don't get as much use as an entrance door, but they have to be much more airtight and watertight than an entrance door to, let's say, a large building would be. Folding doors. So these are products within the scope of NAFS. Now, it's important to realize that NAFS excludes a bunch of products from its scope. Just to be clear, fenestration products not intended to be tested to this standard/specification include, and I'll focus on the ones that might surprise you: sloped glazing. Any skylight that has more than one piece of glass in it is a sloped glazing system. Any skylight that is field glazed is a sloped glazing system. Curtain walls and storefronts are excluded from this standard. Commercial entrance systems excluded. Revolving doors, commercial steel doors. You'll notice that in the initial published version of NAFS 11, it excluded folding door systems. But in 2015, the Joint Document Management Group of the three associations, AMA, CSA, and WDMA, who published the standard, issued a technical interpretation changing that and allowing NAFS testing of folding doors. And folding doors are included formally as a product type in NAFS 17. So they're definitely, you can and should test them to this standard. They're not excluded, is what I'm trying to say. But look at what is excluded: sloped glazing systems, curtain wall. Whether the curtain wall is a cladding system suspended from a building or whether it's standing as a single story or multiple story large window on the ground, that product type is outside of the NAFS standard. storefront is outside of the standard, commercial entrances, revolving doors, and steel doors, hollow metal doors. It's really important to appreciate this because the code now provides separate compliance paths for products inside or outside the scope of this standard. So we have one subsection devoted to products inside the scope of NAFS, and we have another subsection now devoted to products at the standard. So let's take a look at the 2010 National Building Code, because that's the code edition that kind of messed this up. And they got it half right, and they left something important out, which led to a lot of misunderstanding. The 2010 National Code gave us one subsection in Part 5 for windows, doors, and skylights. It gave us one standard for testing products, NAFS and the Canadian supplement to NAFS. And you had to be really interested to read all the way to the bottom of this subsection to Article 510.2.3, structural loads, air leakage, and water penetration, to realize that NAFS was only one way of qualifying structural air and water performance, and the code specifically said where they are covered in the scope of the standards listed in sentence 510.2.2.1, NAFS and the Canadian supplement. So if you read Part 5 carefully, you would have realized there's a scope to that standard, and the standard only applies to the products in its scope. And if you looked at the standard, you would realize all these commercial products did not belong to that standard and were not to be tested under NAFS. But by having only one fenestration heading, many code users concluded it addressed all fenestration products. By having only one testing standard, many code users assumed that standard applied to all fenestration products. As a result, many architects and engineers required these commercial fenestration products like sloped glazing, curtain walls, storefronts, commercial entrances, and commercial steel doors to be tested to NAFS, a standard that specifically excluded these products from its scope. I know that in my part of the country, that has caused no end of problems with project specifications and arguments over how to properly qualify these products, because we'd routinely be getting specs for all of these products saying performance class AW, performance grade, where's your NAFS test report? And of course, those reports did not exist. It appears that the 5-part committee soon got the message and got to work because they fixed that problem in time for the 2015 code. So now let's look at windows and other fenestration assemblies in the 2015 National Code. The 2015 code fixed the problem of how to deal with products outside the scope of NAFS. It renumbered subsection 510.2 as 592, and it left it intact. It's still just the way it was because it applies to NAFS, products in the scope of NAFS. They've added a new subsection 593 named Other Fenestration Assemblies. And these include curtain wall, window wall, storefront, and glazed architectural structures. Basically, glazed architectural structures is everything else that has not been named above or that is not in the NAFS standard. So it includes these named things, but also sloped glazing systems, glass structures supported in a non-traditional manner, point supported, corner clamped, et cetera, et cetera. The code is now very clear about these products, which ones are included and what you do with them. So if we look at 592, it hasn't changed. We still have windows, doors, and skylights for the windows within the scope of NAFS. But we get a new subsection 593, Other Fenestration Assemblies. And for the purpose of this subsection, this refers to curtain walls, window walls, storefronts, and glazed architectural structures. These 4 terms cover everything else that is not in the NAFS standard. So it deals with structural and environmental loads, heat transfer, air leakage, and water penetration and so on. But it's very important when looking at this subsection to read all of the annex notes, because there's a lot of detailed information there. They actually define what they mean by curtain wall, window wall, storefront, what's included under glazed architectural structures. And for every aspect, every performance aspect in subsection 593, there are detailed annex notes. I'm going to feature some of them in this presentation, but you owe it to yourself, if you are dealing with products in this category, to be very familiar with the notes that apply to this part of the code. There are some interesting things here regarding air leakage. Up until now, the code did not specifically give you air leakage targets except in the NAFS standard. So with these fenestration products that are tested to other test methods than NAFS, these other test methods, such as ASTM standards that we use for testing, don't have any defined performance criteria. So the code now actually has defined a maximum level of air leakage for all these other fenestration products. If the products are non-operable, the level corresponds to the fixed level in NAFS. And for the operable products, the leakage level corresponds to the A2 level in NAFS. But it's very interesting that the code also is intelligent enough to recognize that not all systems can comply with these requirements and are not required to comply with the air leakage requirements. So all of them are relevant, but I'm going to focus on the ones that might surprise you. Commercial entrance systems. The entrance doors to large buildings are exempted from air leakage testing. Revolving doors are exempted. Site-built door systems are exempted. Commercial steel doors are exempted. And the annex note tells you why. It says that the systems listed in this sentence perform different functions than other fenestration assemblies and are therefore exempted from complying with the air leakage requirements. In other words, the codes understands that some fenestration products can't walk and chew gum at the same time. Basically, commercial entrance doors, exit doors, egress doors have to be accessible. To be accessible, they have low profile sills. Those low profile sills make it impossible, almost impossible. Essentially, we simply do not have products in North America that have low profile accessible sills that will have a water penetration resistance rating or an air leakage rating anywhere near as tight as what is required for a door that is acting as an environmental separator. What the code is saying is these products are technically, you could say they're exempted from environmental separation requirements. Their primary function is access, it's egress, or they are, or example, the steel doors are typically have been developed as fire doors. And so their primary functions are different. The site-built door systems are a type of product. If it's assembled on site, it's not going to have lab-tested performance. So they just are making it really clear we can't expect these doors. Their primary function is not keeping out the weather. Their primary function is providing access or fire resistance or some other property. Similarly, with water penetration, the code now has a defined level of water penetration resistance using the same thought process as they did with products in the scope of NAFS. Because they are requiring as a minimum water penetration level, these other fenestration products must comply with the driving rain wind pressures calculated in accordance with CSA A440S1, which is the Canadian supplement to NAFS. So we use that same method as we use with the products in the scope of NAFS, and the code tells us use that for everything. If it's curtain wall, use it. If it's window wall, use it. If it's a sliding door, use it. Sliding balcony door, if it's a window wall, that's what you're using for your driving rain wind pressure resistance. But then again, it also exempts the same products that can't walk and chew gum with respect to air leakage those same products are again exempted from water penetration testing. Why? Because they perform different functions. Their main function is not environmental separation. Their main function is something else, and the code is recognizing trying to make them airtight and watertight is a fool's errand. You can add weather strips, you can do all kinds of things. It really doesn't work. So, are these exemptions consistent with prior codes? Has the code changed its mind? Has the code somehow gone nuts here? No. The code has always recognized that occasional incidental water penetration is not a problem if it doesn't do any permanent damage. If you look at section 5.6, it says where a building component or assembly is exposed to precipitation, it shall minimize ingress of precipitation or prevent ingress of precipitation. But then in sentence 2, it goes on to say it's not required where it can be shown that it will not adversely affect the health or safety of building users, the intended use of the building, or the operation of building services. In other words, the code in part 5 realizes we'd like these fenestration products to keep the weather out, but if they can't, it's okay. You can use other methods. You're architects, you're intelligent. You can design around that. You can do what architects have traditionally done, such as recessing doorways back from the face of a building to shield them from driving rain, providing overhead canopies over doorways that are at the plane of the face of the building, using drains, gutters, durable and water-resistant floor finishes, ensuring that water penetration that will get through these doors is not going to provide any deterioration to the building, prevent the use of the building. You design around the weakness of the door rather than specifying a door that doesn't exist. So that's basically the long and the short of it. It's excellent now that the code has very clear guidance about how to handle the fenestration products outside the scope of NAFS. And I think the industry will be pleased with this, and I'm sure architects are going to also find that this provides important clarity going forward in this area. Now that the code has directed us to use how to determine the water penetration resistance required, one of the things I've always been amused by is how often, specifications aren't sure what level of water performance to ask for. And sometimes they ask for something way too high. Sometimes they just repeat, boilerplate language from old specifications. The building code is now clear. Do your homework, use the Canadian supplement methods to specify the required level of performance at your building at the height of the fenestration above grade. So so for the lower 10 meters of the building, you don't need the same level of water penetration resistance as you will higher up the building. And it provides a methodology to help you determine those numbers. So it's a requirement to use this Canadian supplement to NAFS. And it's good practice to have a copy of that standard. It's a good practice to understand it. Honestly, if people would actually read that standard, they'd learn a lot of very important information about the calculation of designed wind pressures and about the methodology that's used in the standard. And it has methods within it that you can do the calculations. But we know, practically speaking, a lot of people don't get around to that. So even though we're, basically Fenestration Canada, when the NAF standard was introduced this performance grade calculator just to make it easier for building officials and building designers to determine the numbers needed for code compliance. And so sentence 59353 requires the use of the standard, and the annex note clarifies that notwithstanding that the other fenestration assemblies are not covered under the testing scope of this standard, they must be tested at the driving rain wind pressure calculated in accordance with the procedure described therein. So The Fenestration Canada Performance Calculator can make this task easier for you. And the nice thing is it can produce a one-page PDF report summarizing your query or analysis that you can file with project documents. If you're a fenestration supplier, you can, document what level of performance is required with a quote or some other document. Basically, it helps you to document your results. So if you want to use that calculator, you can go to this link in the presentation from the calculator, this link in our presentation, or you can search for the words Fenestration Performance Calculator 2017. That will bring up several different search results. You want to make sure to be using the most recent version of this calculator, the February 2017 version that goes with NAFS 11 and A440S117. This is the current standard in the code. The older version of the calculator is available on the website, but is not to be used for new buildings we're working on today. When you arrive at the site, just be sure, looking at the upper left-hand corner, that you're looking at that February 2017 version of the calculator. It's easy to accidentally arrive at the July 13th, or you might click on by your mouse accidentally on the right-hand side here and have it use the 2013 calculator, and you'll see which calculator you're using right here in the upper left-hand corner. As you scroll down a little bit below the main input field of the calculator, you'll notice some definitions. They're pretty important, because one of the things you're going to have to specify here, you're going to have to choose the terrain that the building is in, open or rough terrain. And the terrain definitions are given here at the bottom of the screen. I'm just going to expand them a little bit for you. And it defines open terrain as level terrain with only scattered buildings, trees, other obstructions, open water, shorelines. And open terrain, you can think of it as the prairie or the water equivalent of the prairie. There's basically no substantial protection from wind. Whatever the wind that it's blowing is, you're getting the full force of it. There are no environmental features to reduce the force of that wind. Rough terrain is defined as suburban, urban, or wooded terrain extending upwind from the building uninterrupted for at least 1 kilometer or 20 times the height of the building. Rough terrain looks like the lower part of this picture. It looks like suburbia. It looks like an urban area. It can also look like a forest. Basically, it's topographical features that are rough and that slow down the intensity of the wind, especially near the base of the building. But in order to qualify as rough terrain, you need 1 kilometer of that suburban, urban, or wooded terrain between the open terrain and your building to use the rough terrain category. In the structural commentaries of the building code, you can find the formula for calculating intermittent terrains, but at this level, we're dealing with a very simple go, no go, yes, no kind of situation with respect to open and rough terrain. It's important because you will get a different pressure. Your design wind pressures and your water test pressures will be higher in open terrain conditions. So let's look at the input fields in the calculator and your output fields. While it looks self-evident, I want to point out a couple of things to you. You start with your province, you pick your city, you pick your building type. This example is taken from a Part 9 presentation. You put in your product height. When it comes to large buildings, you can either choose the height of the highest product and specify that level of performance for everything from the roof down. But you will often find that suppliers will want to offer you to break the building up into zones, because if it's a taller building, the design wind pressures at the upper part of the building will be substantially higher in many cases than lower in the building. And you may, if you base your glass design and if you base your reinforcing of the products on that highest load, you might be paying money that you don't need to reinforce everything in the building, when some of these measures might only be needed in the upper stories. So it's just worth appreciating that this evaluation does take into account the height of the fenestration product. Then you do have to choose your terrain type. And then comes an important decision, the performance class. And here it's important to differentiate what is the environmental information versus what is required by the NAFS standard. If you choose R, class R, you are going to get the environmental load on the building. You're going to get the actual design conditions that are going to apply to the fenestration products on that building, whether or not they're in the scope of NAFS. If you are wanting to specify a NAFS product and you choose a performance class that's in your specification, the calculator may increase the minimum performance grade or water test pressure to a level higher than is required by the environment. So, for example, you might be in an area where the performance grade needed for your building is 20 or 25, but if you choose a CW product, by definition, that product has to be a PG 30. So it will it'll increase the numbers, the output numbers based on the performance class. So if you want to know just to meet the environmental load that the building is in, choose the R class, and that will give you the required performance grade, the required positive and negative design pressure for your specs, and the minimum water penetration resistance test pressure for the water tightness performance of the products. A really handy feature of this calculator is that it has a field at the bottom that lets you type in your notes to record why you're doing the analysis. Is it for a specification you're writing? Is it for an investigation you're doing? If you can identify the building, you can identify the project, you can, whatever you need to document your results, you can type those notes into this field, click print, and it will generate a PDF file of your inputs and outputs and your notes for future reference. So that's the ground that we wanted to cover in this presentation this morning. It's morning for me. Sorry, guys, it's afternoon for you. Just a quick review. So the 2010 Building Code, subsection 510.2, titled Windows, Doors, and Skylights, left code users with the impression that the NAFS standard applied to all fenestration products. This led to inappropriate use of the standard for products the standard had actually identified as being outside of its scope. The 2015 code has added a new subsection, 593, that addresses the appropriate performance requirements and testing standards for other fenestration assemblies. And those are the commercial glazing products that are not within the scope of the standard that applies only to windows, doors, and skylights. Subsection 59953, I got that wrong. That should be 593, to be corrected in the next presentation. Introduces maximum air leakage levels that correspond to the maximum air leakage levels in the NAFS standard, and minimum water penetration resistance levels that are determined using the Canadian supplement to NAFS. This presentation introduces code users to the online fenestration performance calculator that simplifies the determination of the required level of water penetration based on a building's location, terrain, and the height of the fenestration product above ground. So there you go. What's new in the National Building Code for fenestration products? A lot that's new and a lot that's good, and we'll be happy to take any questions that we've received. Steph?
Yeah, so we have 2 questions for now, and we'll keep, if they keep coming, we'll keep answering. So the first one is, did you mention replacement jobs also need NAFS certified windows, or did I misheard it?
I didn't talk about replacement windows specifically. I think the question might have to do with the NAFS standard The NAFS standard says that it applies both to new and replacement products.
Okay.
So that's something the NAFS standard says about itself. The building code is a little bit less clear. On the one hand, the building code says that it applies to the construction of new buildings and to the alteration of existing buildings. So technically, if you are replacing windows in a building, that is considered an alteration. And in some provinces, in Alberta, for example, the professional practice guidelines for architects are clear that any building that requires an alteration must engage an architect, and alterations are, include window replacement. And so the expectation is that a window replacement project should be an architect-led project. And there's other conditions that require the engagement of an architect. But the problem is, not a problem, but the reality is, though, that most jurisdictions do not require a building permit for window replacement. So that, provides a kind of a gray area. The code says you should follow the code. Your replacement windows are supposed to comply with the code. That is clear in the code. It's an alteration to an existing building. Your new windows need to comply with that code. It means they might be better, stronger, more water resistant than your old windows. They may have to be more energy efficient than your old windows. So that's what the code requires, but there's no building official requiring you to take out a permit. So nobody's watching what you're doing as a building owner when you're replacing windows.
Okay.
So this is, it's kind of a gray area. A homeowner that wants to replace the windows in their home should be replacing them with code compliant product, but there's no permit required. They're looking for the best price, and the best price may be a non-code compliant window. And so, there's basically no regulation, no enforcement in that area. So I hope that answers the question. The code is clear. They should comply, replacement windows. The reality is that both in small buildings and large buildings, building owners replace windows often without any measures taken to directly address compliance with code.
Okay. Terry's asking, are there any areas in Canada that you know of still using the July 2013 S1 data calculator? If not, should we remove it altogether?
That's a good question. I believe New Brunswick has not yet updated to the 2015 code. Terry, if you could make a note to remind us to address this question. There is a table, there's a National Building Code page with code adoptions across Canada. And so we could go through that page and identify if there's other jurisdictions besides New Brunswick that have not yet adopted the new code. But technically in New Brunswick, the old calculator would still apply, although there's no harm in using the new one. The new one is actually more accurate. In some area, in small buildings, the new calculator actually has reduced pressures from the old calculator. But on large buildings, it's the old calculator wasn't doing as good a job on large buildings. So that was an issue with the Canadian supplement to NAFS where the formulas needed to be adjusted. So if you could just send an email maybe to remind me to look into that, and we'll and we can address that question, because you're right, it might be time to remove the old calculator. Although there might be some value in retaining it for people that are doing investigations of building failures and so on. They might want to know in the code that was in the code that was in effect 5 years ago, what would have been expected under that code? Because technically under law, what was expected under that code would be materially significant in the event of some claim or lawsuit. So there might be reason to consider it. I think that would be a discussion maybe for the technical committee to address. Okay.
Are there specific criteria to define site-built doors?
To be honest, I'm not clear what they mean by site-built doors in the code.
Okay.
That terminology exists in the NAFS standard. The NAFS standard exempted site-built door systems from testing. I suspect that the people that were involved in Part 5 of the code just pulled that language out of the NAFS standard. And I am not sure quite what they mean. It might be something that's, I don't know if in Canada anyone does actually build doors on site from like a kit of parts. Usually these doors are highly fabricated when they come to the job site, and there is some site assembly, but the critical components related to weather performance are usually, factory level work. So I'm not sure quite what that refers to. And if anyone can illuminate this matter for us, I'd really appreciate hearing from you.
Noted. Um, Don's asking how do you decide on using which terrain for new subdivision that has waterfront ocean properties where there will in the future, but currently has no housing yet. Therefore, the middle homes are open for a period of times of week, months, or even years.
Yeah, that's a very good question. And I think that's a question you would have to put to the local building officials. Under the code has climatic data, and the code provides that as guidance for jurisdictions across Canada. But the code also allows local building officials to rely on local knowledge. And local building officials can choose to accept or reject the climatic data in the code. So local building officials ultimately have that authority to make that determination. If you mentioned that these are waterfront homes, the rough terrain only kicks in when you're a kilometer away from the shore. So is that subdivision going to be, going farther inland than a kilometer? Because if it's within a kilometer of the shore, it's going to be an open terrain anyway.
Okay.
But it's a good question. If it is a new subdivision that would be in open terrain today, but when it's built out will be rough terrain, there's a couple of ways to look at that. In terms of design wind loads, those are used, it's a 1 in 50 return period. In terms of the driving rain wind pressures for small buildings, it's a 1 in 5 year return period, the climate data. So potentially your most serious water event could occur. There's a 1 in 5 chance any given year, 20% chance that you're going to get that higher level of water penetration load coming to you. So from a water penetration perspective, it's probably wise to consider it open terrain. From a structural performance perspective, it's probably it may be safe to consider it a rough terrain situation. On the structural performance side, there are so many safety factors involved in determining the design wind loads that that I don't know that there's much risk in going with rough terrain from a wind load perspective, simply because before the 2010 National Code, there was almost no regulation at all of the wind pressure of windows, and those windows are not failing in service. They're not blowing out from the normal winds. Then again, we are entering a period of climate change where we are having, these increasingly frequent storm events with much higher wind pressures than we've had historically. So I think this is really a question for the local building authorities to address.
Okay. Can you please shed some light if fire-rated doors are covered or not in NAFS? My vendor says fire ratings trumps NAFS.
Your vendor is correct. Fire-rated doors are not in the scope of NAFS, right?
Okay.
Remember we talked about the scope of NAFS, and I said one of the products that is excluded from the scope is those commercial steel doors. They are outside of the scope of the standard. They're not intended to be tested to that standard. And the building code, the 2015 National Building Code, says those doors, you can't expect those doors to be watertight. They are exempted from air and water tightness requirements, exempted.
Okay.
So it's perfectly clear. NAFS does not apply to those doors. Neither does the code also tells you you can't expect those doors to perform as effective air and water barriers. You have to use other measures to deal with whatever air leakage or water penetration those doors might experience. As an architect, you need to deal with that in other ways other than expecting it to perform like an environmental separation fenestration product.
Okay. Ashley's asking, I just want to confirm that when reviewing window shop drawings and ratings, that the entire window has to be tested, not individual components, example, glass, frame, etc. Can you accept the lowest rating provided for the window components, or would you need a new rating for the entire window?
I think what Ashley is asking is that some larger windows are assembled from smaller windows. So, for example, you may have a window that is composed of 4 smaller windows that are mulled together to make a large window. So 4 individual window frames are assembled together on site using components from the manufacturer to create a large window.
Okay.
So what is the water penetration resistance of that assembled window? Well, the water penetration and the structural performance of this, the NAFS calls that a combination assembly. It's a combination of assembly of individual products. So to get the performance of the combination assembly, you have to test the whole assembly. Doesn't mean you have to test an assembly of 4 of them together. You could test 2 of them together. What you want to know is when you join 2 or more windows together to make a larger window, you want to know that the joints between them are airtight and watertight to the same level as the individual units. Or if the joint makes it less airtight or watertight, then the performance of that joint becomes the new performance level of that assembled window. You also want to make sure that the structural capacity of the 2 frames joined together, or maybe you're assembling 4 windows together, 2 above and 2 below. Well, you want to know that where all those frames join together, if they're not properly connected to one another, they're not going to resist the wind load. So the individual performance of the individual windows might be quite high. When you start assembling them together in a combination assembly, the individual performance ratings are worthless. They don't tell you, they do not qualify the combination assembly. You either have to test groups of windows coupled together, and that could be very expensive because you can combine them many different ways. The other option we discussed recently on Tech Talks, and it's using the methods in AMA 450. That's a standard that allows a test lab or an engineer to look at all the different ways your individual units can be combined, determine which is the weakest combination, or several of the weakest combinations, so that you can qualify them on the basis of testing. And by testing the weakest combination, you can qualify all of them. However, the weakest combination is going to be weaker than the individual units. So you do need to use one of those methods to qualify the products that are assembled together from individual units. The individual unit ratings no longer apply when you mull them together.
Okay. Rick is saying, I worked in Denver for a window manufacturer in the past. It was normal on the patio doors to supply the glazed sashes, but the frames were sent out, knocked down, and assembled in the field.
Okay. Thank you for clarifying that. I had a hunch that the site-built door type of product might be an American thing.
Okay.
Because it was, that language appeared in the NAFS standard. We didn't have that language in the old A440 standard. And of course, we know that much of the United States has, there's a lot of dry areas where you don't require a high level of water penetration resistance. And site-built doors of that type might be entirely adequate, to meet the needs of the marketplace. I don't know of anyone that would be selling residential patio doors in Canada that would be assembled that way. But that is probably the kind of product that Part 5 has in mind, a product that would be set to the job site in kit form. Parts have been cut in the factory, but they're assembled on site. I don't think it's possible for those products to actually achieve Part 5 requirements. And so, and I don't know that any architect in Canada would consider using those products, in a building constructed to the National Building Code. So, the architect would very much be concerned that the building enclosure would have those properties. Whereas you can't get away from not having an entrance door or a hollow metal door on your building. You have to live with their limited performance. There is nobody forcing you to use a site-built door system. There are door systems that have better performance that are available under the code. So I don't think we use much of that in Canada, but I do appreciate the clarification. And if I'm wrong on what I just said about site-built doors, I would like to hear from someone about that, because I'm talking from my experience and I have not encountered them. So.
Well, about that, someone just wrote, yes, it is done that way. Many vendors ship their large patio doors in knockdown condition to site here in Canada, where the sashes, frames, and sails are then assembled at site, including fold-in doors.
That's okay. Folding doors do.
Yeah.
But here's the thing. Folding doors are now in the scope of NAFS, and they're expected to perform at the job site. And Part 9 of the code doesn't have any site-built door exemption in it that I know of.
Okay.
So, so that's interesting. It's interesting to see how that would play under the code.
Something worth digging.
Something worth looking into. Yes, yes. And I do thank you for pointing that out. Thank you.
And we have Terry saying, for clarity, there may be doors other than steel that could be fire rated. For example, there are fiberglass door slabs can carry up to 20 minutes fire rating, but could /would be NAFS rated. Would be good to know if only steel fire doors are exempt.
So the Part 5 is clear that it's commercial steel doors. I think that was the terminology that were exempted.
Okay.
And in the code, I'm not sure if they use the same language there in Part 5, but yes, they're very clear. They're not exempting fire doors per se.
It's the
exemption to air and water is based on the hollow metal door paradigm.
Okay.
Not on the fire resistance. Interestingly enough, though, I haven't looked at this in the national code, the fire resistance. In the BC building code, the BC building code didn't adopt the language in NBC 2015. They did something similar before the national code did. And the way they did it, they did exempt the products that had a fire resistance rating from NAFS testing. So the BC code did have language related to fire resistance ratings as exemptions to NAFS. I didn't see those in Part 5 of the code.
Okay.
Of the national code.
So someone's saying, if I'm not mistaken, City of Edmonton now allows 20-minute fire-rated doors accepted for requirements of up to 45 minutes on single-family homes for side entrances.
Okay, but like I said, the fire-rated language, I'm not aware that the fire-rated door language would apply in Part 9.
Okay.
It's and whereas I associated hollow metal doors or steel doors with fire rating, the code does not do that in Part 5. They just talk about it as a product type as these steel doors. So we have to stick with what's in the code language here. And the exemption is not because it's fire rated. So.
Okay. That was the last comment / question for now. So, and we're almost at the top of the hour. So just maybe let us know what's going to be your next session. I see it's window testing and labeling.
Yes, the next session is on window testing and labeling. This was a session that I prepared in response to a request from the Fenestration Canada Atlantic Regional Committee for us for a document. They were saying, can you prepare something that would be a simplified NAFS document, something to educate building officials and window and door manufacturers. And I set out to try and have it simplified, but realized if you simplify it too much, people will not realize everything they should know. But the next presentation is a presentation aimed at building officials and manufacturers who are new to the industry or who have not yet done any NAFS testing and want to know about, like, what is this all about? What do I have to do? That's who this next presentation is aimed at. Here's what the building code requires in Part 9 for window and door and skylight product testing and labeling. That's what it'll be about. This is the first time, this regional conference is the first time I'm presenting this presentation. I'm looking forward to feedback from viewers of the presentation as to how it works in that respect, to fine tune it. And potentially it's a presentation that I think could be a slide deck that people could scroll through on our website. Potentially it could also be given as lunch and learns or as virtual conference material, but it's basically what I would call NAFS 100, for building officials, NAFS 100 for window and door manufacturers, your basic gateway entrance to window performance and testing requirements in Part 9 of the code.
So we do have a comment here. Section 9.10.13.1 in Building Code 2015 talks about fire-resistant doors. So
does it talk about them with respect to air and water ratings?
I'm not sure. Like, that's the comment we have, but it's 9.
Okay, just repeat the code section for me.
So 9.10.13.1.
Okay.
So we'll have a look at that for sure. And anyway,
yep.
we do, the tech talks every week, so that might be a topic coming up.
Sure.
In the next few weeks, right? Good. So thanks again to Vecca as presenting sponsors. Thanks again to Everlast as gold sponsors. And what we'll do is that we'll see you guys back at 1:30 to discuss window testing and labeling in Canada. Thanks, Al.
Thanks, everyone.
Thank you.